Hello class, so in this video we're going to be graphing with factored form. First thing, what is factored form? So a function is in factored form if it is in the form of this. So I'm just going to decode this real fast. a1 times x minus x1 times a2 times x minus x2 all the way to a n times x minus x sub n. So what this means is you have some sort of coefficient and then some sort of value. So this is just a generalized form, which is why it looks like this. And yeah, so previously I had a video that went into x-intercepts or roots. So essentially, if you took any of these and set that to 0, you get a root, right? Because this is factored. So a2x minus x2 equals 0. If you were to just solve for that, we end up with x equals x sub 2 over a sub 2, and yeah. So just a quick little review if you needed that. So yeah. Let's work with this then. So essentially factored form is where you have a bunch of things multiplied, because remember, factors are just things that are multiplied together, right? So let's look at these and figure out, are they written in factored form or not? So here we have x plus 4 squared times x minus 1 plus 3. So we have something times something, yes, but we're adding something, so no. How about here? We got something times something. There's no adding outside or anything. It's just all multiplication, so yes, factored form. Here we have 1, 2, 3, 4 things factored. And so here's a coefficient, just a quick example of that. So yes, factored form. Here, you might think no at first because of this. However, actually, these parentheses are unnecessary. So this is the same thing as just saying that, right? So this just equals x plus 3. So this in itself is just a factor of itself. So yes. Okay, let's talk about something called multiplicity then. Multiplicity, you can think of it as the number of times a number is a root of a function. So let's look at this and figure out, first of all, what the roots are. We can pretty easily see that we have 1, -1, and -4. Then there's something called multiplicity. So I'm just going to abbreviate it mult. So here, the multiplicity is actually that. Those tell you the multiplicity. So here, if you think about it in this way, you have 1 and 1 because you have x minus 1 squared. So you're going to have that same root happening twice, basically. And here, you're going to have x plus 1 times x plus 1 times x plus 1. So you'll have -1 as a root basically 3 times, because you can plug that in 3 times. So multiplicity is 3. Here, similar idea, multiplicity is 7. So what in the world does this say about graphs? Well, you can think of it as the number of times the function will intersect the x-axis at a root. So it's just kind of like, in a way, alternating directions. So here's the axis. There's a root. If it alternates going an even number of times, then it's like it goes here, and then it alternates once and goes up. Or hits it, alternates once, alternates twice, alternates again. That's an even number, right? Versus odd will do the other thing. It will go through instead. So that's a bit of the logic of, why that works exactly. So let's just apply that and practice it. So let's figure out what the roots are first. The roots here are clearly -1 and 1. And then they're both multiplicity of 1. So we know that's going to just go through the axis. But is it going to go like this, or is it going to go like that? We can figure it out a few different ways. Easiest way right now is figure out, first of all, what's the y-intercept. Plug in 0, then we'll get -1 times 1, which is -1. So that leaves us with the only option of going like this. And we get a positive looking parabola. Okay, so now let's look over here. We get -1 and 1 again, and then if we plug in 0, we get -1 as the y-intercept yet again. Okay, so what's going to happen here then? Well, we know that at -1, it's just going to hit the axis and bounce back. So here, that's definitely going to have to go upward like that, right? That's just the behavior of going toward an intercept. Then it's going to hit that, go down. At 1, it's going to hit it and just go through, just like that. And quick little thing before we end the video. So if you look at this thing, power of 1, if you multiply this together, you're going to get an x squared type of thing, right? Here, if you multiply it all together, you're going to get something with x to the 5th plus whatever. So what that's actually telling us is a little bit of the behavior of the function. X squared we know is a parabola. It's going to look something like this, right? So this number actually is special as well. This is called the degree. So that is just the highest power of a polynomial. So the highest power will tell us essentially what the function is going to kind of look like. If it's squared, it'll be a parabola. If it's to the 4th power, it'll actually kind of look something like this. So like a little more of like a boxy parabola. And 5th power is always going to look something like this of some sort. It just might be a little bit more boxy depending on what kind of function it is exactly. So 5th, 3rd, 7th, all the odd ones will look something like that. So just a quick little aside about that. Okay, so that concludes it for this video, and I will see you next time.